When a coin is tossed 4 times, find the probability of getting exactly one head, at most 3 heads, at least 2 heads. So here a coin is tossed 4 times. Then they're only asking about heads. So head, 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 and head. So this is one of the possibilities. And the other possibility is tails, 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 and tails. So the probability formula is P plus Q equal to 1. So P is equal to, they are only asking for heads. Heads is 1. So 1. Total is 1 plus 1 is 2. So total is 2 is equal to, so 1 by 2 can also be written as 0.5. So from this we can find the value of Q. P plus Q equal to 1. P value is 0.5 plus Q equal to 1. So Q value is equal to 1 minus of 0.5. So equal to 0.5. So here they are asking for exactly one head. Then we have a formula for binomial probability function. P of x equal to n cx p of x q of n minus x. So exactly one head. So P of x equal to 1. So in place of x, we have to put 1. In place of n is 4 because we are tossing 4 times. So here 4c1, p value is 0.5, whole to the power x value is 1. Next 0.5 q value, n is 4 minus x is 1. So 4 minus 1 is 3 equal to 0.25. To get this value in Cal-C, you have to type, first you got 4. So 4 shift and division symbol. Then 1. 4. This is the value of 4C1. 0.5 whole to the power 1 is 0.5. Then 0.5 into 0.5 into 0.5. If you multiply all these answers, you'll get 0.25. Next, the other question is at most 3 heads. For at most 3 heads, it should start from 0. It should not go more than 3. So P of x equal to 0, P of x equal to 1, P of x equal to 2, P of x equal to 3. So here you have to substitute this formula. So here n value is 4. So x value is 0. 0.5 whole to the power 0. 0.5 whole to the power 4. Plus again next x value is 1. N value is 4. Next similarly like this, here x value is 2, n value is 4. Similarly here also x value is 3, n value is 4. Then here you can see that 0.5 0 is there, 0.5 4 is there. So you can just, since the base is same, base is 0.5, you can just add 0 plus 4 is 4. Here 1 plus 3 is 4. Here 2 plus 2 is 4. Here 1 plus 3 is 4. So from this you can take 0.5 whole to the power 4 as common. So you'll only be left with 4C0, 4C1, 4C2, 4C3 values. So these values are for 4C1, the value is 1. So plus, then 4C1 is 4, 4C2 is 6, 4C3 is 4. All you have to do is 0.5 whole to the power 4, you'll get an answer. Then again you add all this, then whatever answer you'll get, you multiply with this value, then you'll get 0.9375. Next they have asked the question, at least 2 heads. For this P, at least 2 heads, you have to do 1 minus of. They are asking at least 2 heads, only 2 points, x equal to 0, x equal to 1 you have to take. Similarly, same you have to do, 1 minus x equal to 0. When you put x equal to 0 here, you'll only be left with 0.5 whole to the power 4. Then x equal to 1, same formula you have to substitute. Then 1 minus, you have whatever answer you're getting for this, you add it, then subtract it with 1. Then you'll get 0.6875. Next question. The probability that a pen manufactured by a factory be defective is 1 by 10. If 12 such pens are manufactured, what is the probability that exactly 2 are defective, at least 2 are defective, none of them are defective? So in this, similarly we have to use the probability formula. Probability of defective pen, p value is, they have already given, 1 by 10. So you have taken as p equal to 1 by 10. 1 by 10 can also be written as 0.1. From the same formula, p plus q equal to 1, we can get the value of q as 0.9. Next, you'll use the probability distribution function. Here n value is 12 because if 12 such pens are manufactured, so the total value is 12. So n equal to 12. First question is, exactly 2 are defective. So exactly 2 are defective, we have to use p of x equal to 2. So for this formula, n equal to 12, x equal to 2 you have to substitute. Then you'll get the answer as 0.2301. Probability at least 2 defective. Wherever there is at least, you have to put the formula 1 minus, because only 2 defective is there. So p of x equal to 0, p of x equal to 1. Then you'll substitute the values. Then you'll get the answer as 0.341. Next, probability no defective. No defective means the event is not happening. So x will be equal to 0. When you substitute it, you will get 0.2824.